So again, our goal, simplify an exponential expression, and we know an exponential expression is simplified if only positive exponents are left and only one of each base is left. So our first rule today is the quotient of powers rule. Basically, we're saying, what do we do if we divide two exponential expressions? So when we were multiplying, what did we do with the exponents? Add them. We added them. When we're dividing, we need to come up with a new rule. So in order to come up with a rule, we need to do this the longer way first. We need to kind of go old school and say, well, I know what x to the fifth means. What do I mean by x to the fifth? X times x times x. Times x times x. 5 of them. What do we mean by x to the third? X times x times x. So, when we're dividing, if we have the same thing over the same thing, we have an x over an x, I can cancel them out. I can get rid of them. Because, what if I had 5 divided by 5? What is 5 divided by 5? 1. Same thing here. X divided by x is 1. X divided by x is 1. X divided by x is 1. In this case, I don't have to write the 1 in, because if I wrote a 1 in, since we're multiplying, it would just leave whatever else we have in the multiplication problem. So how many x's do we have left? 2. So once again, we want to come up with a shortcut. We want to start here and end here. So I heard a couple people say the rule they thought it would be. Okay? 5 minus 3. If we subtract the exponents, that gives us our 2. 5 minus 3 is 2. So here is our new rule then. If we're dividing with the same base, x to the m over x to the n, that's the same thing as subtracting the exponents. So multiply meant add, divide means subtract, and parentheses meant multiply. So that's kind of the simplified version of all of the rules. Multiply means add, divide means subtract, parentheses mean multiply. So let's look at example 1. Example 1, we have x to the 5th times y squared over x to the 1st times y to the 8th. So our new rule says we have to subtract the exponents if we were dividing. So, what can the x to the 5th combine with? X to the 1st. They have to have that same base. We subtract, and I heard someone say it in the back, x, 4. 5 minus 1 is 4. The second one's a little bit weirder. Okay? Dalton says 2 minus 8, that's going to give me a negative 6. So, negative 6. That's a problem. Why is that a problem? We said to be simplified, we can't have negative exponents. We don't like negative exponents. So we have to figure out something to do with this negative exponent. We have to figure out, what should I do? So that means we need another rule. We come up with one. That first rule said if we're dividing, we subtract. Miana?
If you have a negative exponent on the bottom under the x.
She is correct. Okay, she says we're going to put it on the bottom under the x, but let me show you why that is. So if I went old school again, just with the y pieces, we have y times y over y times y times y. Y, 1, 2, 3, 4, 5, 6, 7, 8. So if we come up with something where we're not sure what to do, we don't have a rule yet, we can always go old school to figure it out. So what cancels with this? What can we get rid of? 2 of the y's. Okay, now this is one of the cases where I do have to write a 1. Before we didn't have to because we were multiplying by stuff still. There's nothing left in the numerator. There's a problem. A fraction has to have a numerator. So we do have to write that they canceled out to be 1. So then if we combine all our y's together, we know this is 1 over y to the 6th. So we know using the rule we came up with and using the old school way, these two things should match each other. 1 over the y to the 6th should match y to the negative 6th. Those are the same. We found them 2 different ways, but we know the answer should match. So the only difference between the two is if we have y to the negative 6th here, it became a fraction and started out as a positive exponent instead. So anytime you have a negative exponent, what it does is it takes the entire thing and moves it. Moves the y to the negative 6th to the bottom. Or if there was a negative exponent on the bottom, it would move, it would move to the top. Now let's look at this one though. We had x to the 4th, y to the negative 6th. When we move something, we do not move the positive exponents. X to the 4th, we're happy with it. But y to the negative 6th does have to move. So this one, we can leave x to the 4th alone. It stays there. And we put y to the 6th underneath. So anytime we have a negative exponent, it only moves the base that it's touching. So it does not flip the x because x doesn't have a negative exponent. So that means our new rule is if we have x to the negative m, that flips to the bottom. It goes to the denominator. So we have 1 over x to the positive m. So there is our second rule of the day. Second exponent property. And again, you have this yellow sheet now, so if you ever forget the rules, you can go reference them quickly instead of having to look through all your various notes. Okay, so we have one more rule to learn, and we have 2 more examples. And then we'll get started on our assignment. So example 2 is just practicing all the rules we've learned today. And we have something a little different. Demetrius, what's different about this example?
There's numbers in front of the x and the y.
There's numbers in front of the x and the y. That changes things. That means we might have to do something a little different. So when we had numbers in front and we were multiplying, what did we do with those numbers? You multiplied them. But this time we're dividing, so we should divide them. If I look at just the 2 over 3, I check and see if I can divide these. Can you divide 2 divided by 3? No. I also check and see if maybe they could reduce. If instead of 2 over 3 I had said 4 over 6, well, 4 over 6 can reduce to be 2 over 3. So you always reduce this fraction, or if it could divide, what if instead it was 10 over 2? Then we could actually divide and get 5. So you always look at this and just consider it as a divide problem. So we have, let me go back. So we have 2 over 3. Those we couldn't do anything with. Go away. So now we look at the x's. The x's can combine together because they have the same base. What should I do with the exponents? Subtract them. 5 minus 4 gives me 1. Then we do the y's. We subtract again. 2 minus 6 gives me negative 4. But I am not done because I have a negative exponent. So 2, 3, x to the first, those will not change. So we just move only the y negative 4 to the bottom, as I think Colton said also. And that would be our final answer for this one. So one more property, one more example.
Yeah.
And then we'll be done with notes for today. So, our last property, x over y to the n. But what did we do with parentheses when we were multiplying? We distributed, we multiplied. Okay. Well, it's going to be the same for this. We still distribute, just we distribute to the top and to the bottom. If we have x to the first and y to the first, m multiplies by both. So x to the first over y to the first, we multiply m times 1, be x to the m times 1 again, and make it y to the m. So just like with multiplication, we still distribute the exponent. So even though the rules look different, they're pretty much the same. That's why we can simplify everything to down to multiply means add, divide means subtract, and parentheses mean multiply. Those are the simplified form of all of the properties. So we have one last example. The problem with having so many properties is we can do a lot. There is a lot going on here. And in fact, I wanted to change one more thing. I'm going to say times q to the 8th. So yeah, there is a lot going on here. We have to figure out what do we do when there is so much going on.
Walk away.
We don't walk away. Never give up. Never surrender. Probably don't recognize the quote. Anyone seen Galaxy Quest?
No.
No. It's too old school. So, when we have a problem like this, we always start by simplifying the numerator and simplifying the denominator. We want to get this as simplified as we can. And we want to get the bottom as simplified as we can. We do not want to try and simplify stuff from numerator to denominator. We don't want to try and combine those things together until they're already simplified. So on its own, the top needs to be simplified. That means the top needs to have only one of each base and no negative exponents. On its own, the bottom needs to be simplified. That means it needs one of each base. So let's look at just the top right now. We're going to completely ignore the denominator for now. Just the top. Okay. So I heard someone say distribute. Distribute what's in the parentheses. Now, the problem would not have the ones written in, but I forgot to erase those from the last class. We have to know that 2 on its own has an exponent of 1. q on its own has an exponent of 1. So we have to distribute these first. So this first part I haven't even done anything with. I'm going to write 3p cubed q squared again, because I have not done anything with them. Xander, you need to stay awake for this. So we distribute the exponent in. 1 times 2 would give us 2. So we have 2 squared times, now we have to multiply some fractions again. 1/2 times 2. How can I make 2 a fraction? And I multiply straight across. 1 times 2 is 2 times 1 is 2. Am I hearing? Oh, that's my phone. Sorry. Oh. Like, I swear I hear music. What's 2 divided by 2? 1. So this one simplified to no longer be a fraction. P to the first now. And then we distribute still. We have 2 times 1 for the q squared. Now, we said with numbers we want to actually multiply them out. What is 2 squared? 4. 2 times 2. So I'm going to just cross it out and put a 4 in its place so we don't have to write the whole thing another time. So now let's look at the denominator. Six has nothing to combine with right now, so we leave it alone. What about p to the -2? What should I do with that to make it simplified? Put it on the top. We have to move it to the numerator. So now we have times p squared in the top. This had to move up. What about q to the 0? 1. So basically, anytime you have a variable to 0, cross it out. We can just get rid of it. You only have to write the 1 if it's going to end up being the only thing left in the numerator. And then q to the 8 has nothing else to combine with, so we write it as q to the 8. Xander, you're still sleeping. Get your head all the way off your desk. So we are almost ready to finish. We still need to simplify the numerator completely. So in the numerator, I have numbers I can multiply together. 3 times 4 gives me 12. Now I have multiple things I can combine for the p's. What will my new exponent for my p's be if I have all of them added together? P6, 3 plus 1 plus the 2, P6, and then Q4. And then the bottom was already as simplified as it could be. Now that the top is simplified and the bottom is simplified, now we can combine top to bottom. So now we look at all the like things from top to bottom. So we have 12 over 6 first. Can that simplify? 2. We are not subtracting, we are dividing. They are not exponents, they do not follow the properties of exponents. That is one of the most common mistakes people make. You have to be on the watch for that. Okay, what about P? Leave it. Nothing to combine with. And then Q? 4 minus 8 is -4. So we move it to the bottom. It's really 2p6 over q to the positive 4. So it is a longer process when you have so many properties together. You do have a lot of properties that we have to be able to combine, and it's not always going to be in that order. Ready?